What is a nutrient cycle? Well, it is defined as the movement and exchange of organic and inorganic matter back into the production of matter. So, a nutrient cycle describes the use, movement, and recycling of nutrients in an environment. These can include feedback loops for many essential elements like nitrogen, carbon, and phosphorus. To explain this, we'll use the nitrogen cycle as an example, because nitrogen is a key component to the biology of all living things. Nitrogen atoms are found in all proteins and DNA, and it is often a limiting nutrient. This means that it is in very short supply, and hence limits growth in a given area. This may sound weird when you consider the fact that nitrogen makes up most of the air around us. The problem is that this nitrogen is N2 gas, which plants and animals can't use or even change. That's why bacteria are so important to the cycle. They convert the atmospheric nitrogen in the air to usable molecules like ammonia. This is called nitrogen fixation. Plants take up these molecules and animals eat the plants. Some nitrogen is lost by these animals when it is excreted as waste, but once it dies, then denitrifying bacteria begin making N2 gas out of the nitrates and nitrites in the animal, thus beginning the cycle again. Humans can have significant negative effects on natural nutrient cycles. For example, if a farmer over-fertilizes their land, nutrients like nitrogen and phosphorus can drain into lakes and streams. With an abundance of nutrients, there can be an algae bloom, which is a sudden and rapid growth of algae. The demand of oxygen from these algae can cause hypoxia in other organisms. The health of the fish and plants will gradually deteriorate as their oxygen levels drop. Another way in which nutrient cycles can be harmed by humans is with acid rain. As emissions from vehicles, oil refineries, and power stations mix with water vapor in the air, they form acids. Not only do these acids dissolve limestone structures, they also lower the pH of lakes. The lower pH inhibits nitrifying bacteria, laboring the nutrient cycle. If the pH drops to 4 or below, the cycle is so disrupted that the lake is considered dead. Humans can take advantage of nutrient cycles in aquaponics systems. The efficiency of nutrient cycles is fundamental to the success of a system. To ensure the nitrifying bacteria can operate at good levels, the pH of the water is closely monitored and maintained. With the pH at appropriate levels, the next thing to consider is the actual levels of nutrients in the system. Returning to our nitrogen example, it enters the system as protein in the fish food, which the fish then break down into ammonia and ammonium. The fish excrete this ammonia and ammonium into the water, allowing the bacteria to turn them into nitrites and then nitrates for the plants to consume. The effective use of nutrient cycles is fundamental to the success of an aquaponics system. In order to meet the world's growing food demands, we must move toward more sustainable, renewable, and urban farming techniques. To achieve this, we must preserve natural nutrient cycles and learn how best to replicate them in our own man-made environments.